Okay, welcome to your first Math Bootcamp video. This is Math Skills 1. It'd be very helpful if you got out your math reference sheet while we're going over this video so you can refer to that as we're working at problems. Okay, so the first thing we're going to discuss is how we write really small or very large numbers in chemistry. We're going to be dealing with these quite often. So we're going to be using what's known as scientific notation. Hopefully this is something you are familiar with. Basically what you have is a number that is somewhere between 1 and 9 multiplied with 10 to some sort of exponent. The exponent tells you how to move that decimal. This little format right here is actually written down on your reference sheet, so you don't really need to write this down because you already have this, but I do want you to work out the example. So let's look at this number. This is a very, very small number. So what we're going to want to do is we're going to put the decimal somewhere in this number so that we can create a number that is between 1 and 9. So the best place to do that is right here between the 3 and the 2. So that's going to be our coefficient, and then it's going to be times 10. So now we needed to figure out how many times we need to move that decimal back to get to the original number. So if you count with me, it's 1, 2, 3, 4, 5. It's going to be a 5, but I had to move it back to the left, and so that means it's going to be a negative number. If I had to move it back to the right, it would be a positive 5. Our next example is already in scientific notation. So if you see, we have a 1.5 times 10 to the 4. 4 is how many times we need to move the decimal, and since it's positive, we're going to move it to the right. So if we move that over, it's going to be 1, 2, 3, 4. Fill the empty spaces in with zeros, and that's how you convert out of scientific notation. Okay, so since we're going to be using scientific notation numbers quite frequently, you're going to have to be familiar with how to type them into a calculator. So if you use our scientific calculators, you're going to have to push the second, and then it's the button right above the 7, which is x to the negative 1. The reason we're pushing that button is because we want the e to pop up. The e is very useful to us. It saves us a lot of time because it actually equals times 10 to the something, and so it just saves us a lot of time when we're typing these in. So I have an example of a number that you could be given, 6.35 times 10 to the negative 12. If you were going to type that in your calculator, you would type in 6.35, so that's not going to change, but instead of typing all of this mess in, we're going to type in the e, so second, and then the button above the 7, and then all we have to do is fill in what the exponent is after that. Okay, so the next thing we're going to discuss is how we know how precise a number is. And so what we're going to be doing is known as counting Sig Figs, or significant figures. There are 5 rules that you already have on your reference sheet, so I'm just going to go over each one individually. So the very first one is non-zeros are sig figs. So anything that is between a 1 and a 9 is counted as a sig fig. So for example, 230, there is a 2 and a 3, which are both non-zero numbers, so this number has 2 sig figs in it. Okay, so the next 2 rules that we're going to go over are sandwich zeros and zeros that are in the front. Okay, so sandwich zeros basically means that it's in between 2 significant figures. So for example, 203, we have 2 and 3, which are non-zero numbers, so those definitely count. So now the question is, does this 0 count? And it does, because it is in between these 2 sig figs here. So there's 3 sig figs in this example. Okay, the next rule we're going to go over is zeros that are in the front of sig figs, also called leading zeros. These are never, ever, ever, ever going to be significant. So for example, we have 0.005. That's a lot of zeros, so people tend to want to count those. But none of these are significant. The only significant figure in this whole number is going to be 5 because it follows rule number 1. It's a non-zero number. So this number actually only has 1 sig fig in it. Okay, so the trickiest rule is rule number 4. This has to do with trailing zeros, or zeros that are behind significant figures. They will count if there is a decimal in the number. It doesn't matter where it is, where those zeros are in relationship to the decimal. As long as there is a decimal, it will count. So for example, we have two values here that both equal each other. They're both 200, but one has more significant figures than the other. If you look at the first example, the only significant figure in this whole number is the 2. The trailing zeros behind it do not count because there's not a decimal in that number. The next example, the 2 still counts because it's a non-zero number, but now I can count these zeros because there is a decimal right here in the number. So this one actually has 4 sig figs. Okay, so the very last rule is rule number 5. When we're looking at scientific notation numbers, the only part that we don't count as significant for sure is going to be the 10 to the exponent. So looking at this, we're just going to ignore this whole part. That is part of the number, but when we're counting sig figs, it won't. So I'm going to go ahead and count the 4 and the 6 because those are non-zero numbers. So now let's look at our zeros. I have a sandwich 0, so that's going to definitely count. And then I have a trailing 0, and it is going to count because there is a decimal in the number. So I have a total of 4 sig figs in this number. Okay, so the next thing we're going to discuss is how we measure substances. We're going to use what are called SI units. It's an international system of units. Basically, it's all of the units that we don't use in America, but it's used in the rest of the world. There are 3 base units that you need to be familiar at this moment. There are meters, grams, and liters. Meters measure distance, and grams measure mass, and then liters measure volume. So just know that these are base units. Very important because I'm going to be referring to that a lot. The next thing we're going to be talking about when we discuss SI units are prefixes. So something that goes in the very front of those base units would be a prefix. No matter what that prefix is, they are always the same value no matter what base unit they are in front of. So that's something that's very important that I want you to write down before we move on. Okay, so this is your metric conversion chart. I just want to draw attention to a couple of things on here before we move on. So take a note that there are 2 columns. On the left side is the base unit side. On the right side is the prefix unit side. So whatever number you see in the left column, that is the number that is going to go with your base unit when you're converting. The number that is on the right side, that is the number that is going to go with your prefix unit. So some of these prefixes you're probably very familiar with, like centi, milli, and kilo. Some of these you've probably never heard of. Take a note, the ones that are at the top are very large prefixes, and so we use these whenever we're trying to measure very large things. And on the bottom are prefixes that we use when we're trying to measure something that's very small. Take a note as well that these 2 things, a row, is equal to one another. They are equivalent, and because of that, we're going to use these when we do conversions. Okay, so this is probably the most important part of the video. How do we convert SI units? We're going to be going over something called dimensional analysis for the next couple of days, and so I want you to take the time to pause this and write all this down. What dimensional analysis is, it is a way that we convert units by creating a series of fractions. I'm going to call it a grid for the rest of the year. Dimensional analysis is extremely useful. This is something you're going to be using for the rest of your high school career in your science classes. Dimensional analysis works because of 2 reasons, and I want you to write these down as well. In that grid, we have fractions. The numerator and the denominator are equivalent, so that means that they are considered to be equal to 1. If you multiply anything by 1, it does not change that value. So dimensional analysis works because the value is going to stay the same. The only thing that is changing is the unit, which is exactly what we're trying to accomplish. Okay, so let's work out an example of dimensional analysis, something that you're going to be seeing tomorrow in class. So this problem says that we want to convert 14 centimeters to meters. So we are going from centimeters to meters, and this is going to be a one-step conversion, which is not very important right now, but it will be when we move on to the next video. So what you do is you set up your dimensional analysis chart. We are given 14 centimeters. The thing that you are given always starts your chart in the top left corner. The bottom left corner can stay blank, or you can put a 1 there. I always keep it blank because I don't have any reason to write a 1 there. So that's how you start out your chart. Now how do you move on to the next step? We're going to create a fraction on the right side here that is going to be equivalent to each other. But before we do that, let's go ahead and fill in our units. Now I'm starting with centimeters and I'm trying to get to meters. The unit that you're trying to get to is going to go on the top, and the unit that you're trying to get away from is going to go on the bottom. The reason we're doing that is because if something is on the top and on the bottom, it's going to cancel each other out, leaving you with the unit that you want to convert to. So now the question is what goes here and here? These are numbers that you have to find on your metric conversion chart. So let's take a look at that and see where you can find those numbers. Okay, so recall from that problem, we're going from centimeters to meters. Basically, the prefix tells you which row you need to refer to. So we're dealing with centimeters, so we're going to look at this row right here to figure out which number goes with which thing. So on the base unit side, I need to put a 1 with my base unit, which in this situation is meter. On the other side, the prefix side, it says that that is equivalent to 100 centi something. So a 100 is going to go with the centimeters, and then a 1 is going to go with the meters. So let's go fill that in our grid. Okay, so now I'm going to fill in those numbers that I just found on the conversion chart. So it said a 1 went with the meter, and a 100 went with the centimeter. So once you have your units and your fraction filled in, now you can do the actual math. In dimensional analysis, everything across the top gets multiplied and everything across the bottom gets multiplied, and then it's top divided by bottom. So in this situation, there's absolutely no reason we have to type in 14 times 1 in our calculator because we already know that that's going to be a 14. And there's nothing down here in the bottom left corner, but remember that's just a 1. So 1 times 100 is just going to be 100. And then it's top divided by bottom. So what I would type in my calculator is 14 divided by 100, which gets you 0.14. Now, that is a naked number. It doesn't have a unit behind it, which is an unacceptable answer in my room. So how do you know what the unit is? If you look at your dimensional analysis chart, centimeter is both on the top and on the bottom. So that means it's going to get canceled out. The only unit that we are left with in this chart is meters, and so that is going to be the unit for our answer, and conveniently enough, that is the unit that we wanted to convert to. Okay, so just to summarize the video, you better have a couple of examples for significant figures written down, as well as working out scientific notation numbers and how to type those in your calculator. And then you definitely need to have the notes as well as the example problem for dimensional analysis written down. So be prepared to work out these math skills tomorrow in class.